Hello class. In the last video, we studied the equation of motion of a simple harmonic oscillator. Okay? And it was a differential equation of the second order. It was in the form of x double prime, which is the derivative of x 2 times, k over m times x equals to 0, where we set it that k over m equals to omega 0 squared. And we called omega 0 the proper angular frequency. We are going to study what's the exact meaning of the angular frequency in a second video, but now just take it as it is. And the solution of this differential equation is x equal to xm sine omega 0 t plus theta, and this solution we call it the time equation of motion of this simple harmonic motion. Okay, now in this video we're gonna stop a bit with the physics and we are gonna have like this mathematical break. We are gonna study, like in this mathematical break, the variation of the sine and cosine functions. We're going to study the derivatives of sine and cosine and the differential equation of second order, and finally we're going to have a glimpse of the exponential function. In this video we're going to study the sine and cosine functions and how we're going to draw them and the significance of each component. Okay, so first consider the following sine function. X, which is a function of time f of t, equals to a sine omega t plus phi. Okay, x is a function of time and a, omega and phi are all constants. So x is a function of time, a, omega and phi are all constants. Okay, now we know that any sine, let me put it here. Okay, we know that any sine function is bounded between the value -1 and +1. So the value here, omega t plus phi, is a value that is dependent on the variable t, on time, but altogether, because it's inside the sine function, it is just an angle. Okay, it's just an angle, but this angle is variable with respect to time. Okay, but all of this is an angle. So the sine of anything is bounded between -1 and +1. To explain that, we are going to draw the trigonometric circle. So the trigonometric circle is just a circle which has its radius equals to 1. So it's a unit circle. Unit because the radius, equals to 1. Okay? The horizontal axis is the cosine and the vertical axis is the sine. Okay? Now any angle here, any angle theta, will have a specific cosine and a specific sine. Okay? That's how you can measure the sine and cosine of a specific angle using this trigonometric circle. Now, we are gonna just take special cases of this angle theta and see. In case the angle was 0, so it's here. The sine of angle 0 is 0 because here's the origin of this axis. So the sine of 0 is 0. If we go a bit up and we have the angle pi over 2. Sine of pi over 2, because look, the angle is all the way here. Where's the sine? It's on the circle, so the sine would be, and the radius is 1, so the sine would be 1. So the sine of pi over 2 is 1. Now let's go a bit here. Now we have the angle. All of this is the angle pi. And now the line is here. So the sine of angle pi is, let me show you, the sine of angle pi is 0. So 0. Let's go now down a bit. Now we have the angle pi plus pi over 2. It's pi. All of this is pi, and plus pi over 2, it is 3 pi over 2. So we're talking about this angle here, and the sine of that is not plus 1, it is minus 1. And then we will continue all the way now here. So it is pi, another pi, that's 2 pi. And again, the sine would be 0 because the angle 2 pi would be here and the sine would be 0. Okay, we're like doing a projection. Here's the sine axis, here's the angle 2 pi. We project on this axis, it is 0 here in the origin. Okay, and you can see that the maximum value of sine is plus 1, minimum is minus 1. So the sine function, whatever the angle was, because based on this trigonometric circle, which the sine and cosine was defined on it, sine is bounded between minus 1 and plus 1. Okay, now our function actually is a sine omega t plus phi, not just sine omega t plus phi. So we have to multiply by a to get our function x. So a times minus 1 is minus a sine omega t plus phi, and a times plus 1 is plus a. All of this here is x, so we have x is bounded between minus a and a. We have a function x that is bounded between two values, minus a and plus a. This is very similar to saying that we have a function that's minimum is minus a and its maximum is plus a. So we call a the amplitude of the function, or of the function x. And because we want the amplitude to be positive, we will take the absolute value of a and we call it the amplitude of, the amplitude of x. Okay, so x is bound between minus a and plus a, so it alternates between minus a and plus a, minus a and plus a. Thus, a would be the amplitude of x. Now we knew the significance of the constant a. I'm going to study now another function, not a sine function, but a cosine function. And we're going to see something similar to this. So, now let's take also x equals to a cosine omega t plus phi. And x is just a function of time, and a omega and phi are all constants. This function here and the other function up there, x would be, because it's a position, we're going to take it in centimeters, and t, because it's time, we're going to take it in seconds. Okay, it's the same function, but instead of having sine, we have cosine. And again, cosine, just the way sine is bounded, cosine any angle, we're going to take omega t plus phi, is also bounded between minus 1 and plus 1. You're going to ask me now how that's also bounded. Again, we're going to explain that using the trigonometric circle. Okay? I'm going to draw again the axis. So this is the cosine, and here is the sine. Remember, the vertical one is it's the sine, and the horizontal is the cosine. Okay? Again, when the angle is 0, so it's here, we project on the cosine axis, and the projection would be all the line. So when the projection is all the line and it's a unit circle, r equals to 1, all the line is 1. So cosine would be 1. Now, if we move up a bit, and the angle now is pi over 2. So our angle is up here. Project again on the cosine axis, and the projection would be here, this point here. And that point is the origin, which is just 0. Now, we're gonna shift again, and the angle now is pi plus over 2 plus pi over 2, that's a whole pi. The angle is here. Project again on the cosine axis, and it's the whole line but in the negative side, so that would be -1. Then I'm going to change the color, I'm going to use green. We're going to do the whole angle here, which is pi plus pi over 2, that is 3 pi over 2. And the projection of this line here is on the origin, which is again 0. Now let's do a full circle. The full circle would be all of this, which is 2 pi. Again, the angle here, it's the same as having the angle 0. And again, the cosine of 2 pi would be 1. So you can see that having a full circle, the value of cosine alternates between 1, 0, and -1. So the value of cosine is bound, we call it's bounded between -1 and +1. Again, to get the function x, we have to multiply by a. So we multiply by a on all the sides of the inequality. And we have minus a cosine omega t plus phi, and plus a. So cosine omega t plus phi is sandwiched between minus a and plus a. All of this here is x, and we have minus a, so x is bounded between minus a and plus a. It's the same thing, so the sine function and cosine function, they're both bounded between these two, -1 plus 1. So the x would be bounded between minus a, and again, we call this a, we're going to put it in the absolute value, we call it the amplitude of the function x. Okay? Now we learned the meaning of this amplitude, the meaning of this a, and since it's the amplitude, then it would be the maximum value, so we're going to call it xm. Okay? Now you can see what's the meaning of xm. Xm is just the amplitude. Let me write it down in a nice way. So a, which is equals to xm, which is the maximum value of x, is the amplitude of the function x. Okay? So we understood what's the meaning of a. Now there are still the two constants, omega and phi. Let's first try to understand what is the role of phi. Okay, so we're going to ask a question here. What is the role of phi? What's the role of phi? We're going to try to understand the role of phi by taking these two sine functions. So the first function I'm gonna call it x1 equals to 2 sine 2t plus pi over 2. And the second one is x2 equals to 2 sine 2t. So if it's only 2t, so the phi would be just 0. In this function x1, let's put a nice color. Pink is nice. So the amplitude equals to 2, omega equals to 2, and phi equals to pi over 2. Here, the amplitude as well equals to 2. I'm going to take it to 2 centimeters. And here is 2 centimeters as well. Centimeters. And omega equals to 2 as well, but phi equals to 0. So they are the same function, but what differs is the phi. We call this phi the phase. Okay, let's see what does this phase do. To understand what does this phase do, we have to draw the function x1 and x2 with respect to time. So here we drew the graph. We have the graph of x as a function of time, and the x-axis, which is the vertical axis here, is divided at each 2 divisions is 1 centimeter. So all of this here is 2 centimeters, here's minus 2 centimeters. And in the horizontal axis, the t or the time axis, each 2 divisions is 0.25 pi. Okay, now let's try to draw this function together. Let's take here, so let's go a bit here. So for x1, we're talking about x1. For t equals to 0, x equals to 2. Let me go back to our function. 2 sine 2t plus 2 pi. So here. So 2 sine 2, 0 plus pi over 2. That's 0. It's 2 sine pi over 2. We already know from the trigonometric circle that sine pi over 2 equals to 1. So 2 times 1 is simply 2. So the first point, let's choose a green color. The first point as t equals to 0, x equals to 2. That's the first point. Now, let's go back here. For t equals to, so the second point is pi over 4. So for t equals to pi over 4, x would be 2 sine 2 pi over 2 plus pi over 2. I'm sorry, 2 pi over 4, that's pi over 4. 2 pi over 4 plus pi over 2. That's equal to 2 sine pi over 2 plus pi over 2, which is equal to 2 sine pi. Now, sine pi, as we saw, is 0. So 2 times 0 is simply 0. So the second point would be here at pi over 4, x would be 0. Okay? Now, let's do a third point down here. Let's change the color. So, for t equals to pi over 2. Here was, let me see, pi over 4, now pi over 2. X would be 2 sine 2 pi over 2 plus pi over 2. 2 pi over 2, this will go with this. You will end up with 2 sine pi plus pi over 2. That is simply 2 sine 3 pi over 2. And you know that sine 3 pi over 2 equals to minus 1. So 2 times minus 1 is minus 2. So the point here at pi over 2 is minus 2. Okay, now let's try for 3 pi over 4. So here, for t, let me just see, yeah, okay. For t equals to 3 pi over 4, x would be 2 sine 2 3 pi over 4 plus pi over 2. This will go with this, and we have 3 pi over 2. So 2 sine 3 pi over 2 plus pi over 2. That is simply 2 sine 2 pi over 2, which is just pi. And we know that sine pi is 0, so that would be 0. So here, 0. Now, again, let's do the value of x for t equals to pi. Take space here. Now, for t equals to pi, sine x would be equal to, sorry, don't think there's enough space here actually for this. Let's do it here. So for t equal to pi, x equal to x equals to 2 sine 2 pi plus pi over 2. That is equal to 2 sine 5 pi over 2. 5 pi over 2? Yeah, 5 pi over 2. And that would be equal to 2 sine. You know that 5 pi over 2 is simply 2 pi plus pi over 2. That's just pi over 2 because you have a full circle, and over a full cycle then pi over 2, that's just pi over 2, and the sine of pi over 2 equals to 1, so that would be 2. You understand what I mean? I'm talking about here. So pi over 2, 2 pi plus pi over 2, that's just as if we're talking pi over 2 because we did a full cycle and then we continue to the pi over 2. Okay, so that will be just 2. So we're gonna put the point up here. This is not the right one. Up here. So if you want to draw this line or this graph, it will look something like this. We start at this point here, go down, now to the minimum, back to 0, maximum, and so on. If you want to continue, it's going to be like this. If you try to continue with your calculations for t equals to 5 pi over 4 and for t equal to 3 over 2 pi and so on, it's going to just look like this because it's a periodic function. And so on. Okay, so this is the function, or this is the drawing or the figure or the graph of function x1. Now let's try to see the graph x2. Let me just move this up here. No, not like this. Okay. Can't move? No, it can. Let me copy and paste it here. Okay, now let's try to do the graph for x2. So, for x2, we know that again, x2 is just 2 sine 2t. Phi is just 0, okay? So 2 sine 2t. For t equals to 0, x would be, or x2 would be 2 sine 0, and sine 0 is just 0, so that would be 0. So the first point is here at 0, 0. Now, for t equals to pi over 4, x would be equal to 2 sine 2 pi over 4. 2 pi over 4, that's pi over 2, so 2 sine pi over 2. And sine pi over 2 is 1, so that would be just 2. Let's go up here. And for t equal to pi over 4, x equals to 2. Again, for t equals to 0.75 pi, that is 3 over 4 pi. X would be 2 sine 2, 3 over 4 pi. That is just 3 over 2. So 2 sine 3 over 2 pi. I think we missed the point. We missed for t equals to pi over 2. I'm going to do it again. So for t equals 3 over 4 pi, we have 2 sine 3 over 2 pi. We know that from the trigonometric circle, sine 3 over 2 pi is just minus 1, so that would be minus 2. Let me plot this point. So here, for 3 over 4, it's minus 2. Let's just redo the pi over 2. I'm going to redo it here. 4. T equals to pi over 2 sine 2 pi over 2, that's x equals to 2 sine 2 over 2, sine pi, 2 sine pi is just 0, so that would be 0. So this point would be here. And we're going to continue doing these calculations, and we're going to have for t equals to pi, x would be 0, and for t equals to 5 pi over 4, x would be plus 2, and etc. You can just do the calculations. Let's plot these 2 points. You can see actually the pattern, how it's going. So we start, let me change the color. We start at 0, go to the maximum, back to 0, go to the minimum, back to 0, maximum, and so on and so forth. If you continue doing the calculations, because it's a periodic function, so obviously it's going to be like this. And so on. So let's see now the difference between these two functions, or these two drawings, these two figures. You know that they are all the same, but the only difference is phi. In the first one, phi equals to pi over 2. In the second one, phi equals to 0. Let's see what is the role of phi. What does the difference in phi changes in the function x1 and x2? So x1 and x2, the only difference between these two periodic and these two periodic functions, they have the same amplitude too, and they have the same period. So every pi we're noticing the same up and down. It alternates every pi, so the full cycle is for pi. But the difference between these two functions is that the starting point or the initial abscissa is different. For x1, when phi was pi over 2, the function starts at the maximum at 2 here, whereas here the function starts at 0. So we can say that the function of phi is to determine the initial abscissa. For when t equals to 0, we have the phi. So it determines where the function starts. So let us write it down. The role of the phase phi is to determine the initial abscissa. Okay. Now, in the second video, we are going to study the derivative of sine and cosine functions, and then after that, we are going to have a glimpse of the differential equation of second order, and finally, we will study a bit of